Hi everyone. Today I'm going to show you how to reverse a linked list. Imagine we start with a linked list that points from 1 through 5. After the reversal, we would expect the linked list to start from 5 and pointing through to 1. We start with 3 pointers: previous, current, and next. The first step of this algorithm would involve setting previous to null. The reason we do this will become clear towards the end of the algorithm, but basically what we want is that towards the end of the algorithm, we want the new tail to be null. And we set current to the head of the list, the beginning of the list, which in this case will be 1. For the while loop, it's very important to set a terminating condition so that the while loop doesn't go forever. In this case, we want the while loop to stop once current has reached the end of the list. Hence, we do current is not null. Null here would mean that current has reached the end of the list. So the first step involves initializing next. We set next to the node right after current. In this case, imagine if we are currently at 2, we would want next to point to 3. Then we change the pointer of current to point to the node right before it. In this case, we do that by doing current.next equals previous. So 2, which was initially pointing to 3, will now point to 1. Then we change previous to become the current pointer. Basically, we take previous, which was at 1, and now point it at 2. And then we take current, which was at 2, to point to next, which is 3. The reason we need to do this shifting is because at any point we do not want to lose access to the nodes that we are changing. For instance, now 2 is pointing to 1 and 3 is pointing to 4. So the link between 3 and 2 is lost. However, since we have previous pointing to 2, we can still access 2 in the next step of this iteration. So once we go through this, we will have a reverse linked list, which starts from 5 and points through to 1. The time complexity of this algorithm is O of n because we are going through all the nodes in the linked list just once. And the space complexity of this algorithm is constant because we are changing the linked list as it is and not making a copy of it anywhere. This algorithm can be represented using the Python code shown here. Thank you.